Hello, good evening, everybody. Welcome back to our session. We are now in panel G. It's about open data and open source benefits and case studies. Today we'll be having two distinguished speakers. Let me first introduce Mr. Rodrigo Pinto. Rodrigo Pinto is the head of technology at Zendy, Dubai. He has actively collaborated in open source initiatives such as CRMs, plugins, ERP solutions. His education is simplifying complex problems and harnessing the power of AI people, his professional journey. Please allow me to welcome Mr. Rodrigo again. His presentation will be about leveraging big data and machine learning to enhance open data quality insights for developing regions. Please, stage is yours.
Thank you. All right. Thank you everyone for coming, and thank you for the introduction. As mentioned previously in the introduction, my background is mostly in software development, software architecture. But throughout the last 5 years, especially working at Zendy, I have come to the realization of the use of the AI tools and big data tools to leverage big data initiatives in order to have quality of data. So throughout this presentation, I'll be showcasing how to use these openly accessible tools in the open data ecosystem to leverage its use, especially for developing regions. So first, most of you know about the benefits of open data in developing regions, right? Just to name a few, and the impact it can have in developing economies, promoting economic growth, enabling innovation, improving products and services, right? Now, and those are just to name a few, of course. Now, this comes with a few challenges, always. And just to name a few, we can name harmonizing open data, the limited amount of data available, and the open data quality. We will focus mostly on harmonizing data and the open data quality. In terms of limited data, and especially in this digital era, the tendency is that there will be more and more initiatives, and eventually the limited data won't be a problem. But the other problem as a collateral will be that we will need to continuously deal with bigger and bigger data sets, more complicated and from different sources. So let's drill down into two of these issues. Harmonizing open data. There are a lot of initiatives available out there, and they keep growing as well. They come in different formats as well, and they are hard to process, right? There is no gold standard, and this is for everything, not only for open data. For open source, there is no single programming language. There is no single way to do things, and also there is no single format to process data, which it's a problem when we want to unify this data, right? So in order to do this data unification, and make it available for domain specific. In developing regions, especially, you might need to have a database of medical records, right? Unified with your own medical rules, or a database or a library for lawyers, right? Adapted to the needs of local governments. How to unify them? It's it's such a challenge because you need to check which data is useful for you, which data is not, when you are talking about millions of records, right? So the challenges on this is processing power, right? You will need a lot of servers and a lot of processing power to accomplish this. You will need data scientists or people expert in data, academics and whatnot, spending tons of time analyzing these records, trying to unify, trying to find patterns and whatnot. And software licenses. Even if you find a way to automate these things, you will have to purchase licenses or hire, outsource the effort to a company to, and hence you will be incurring in costs and so on. The other problem we have is data quality. The problem with data quality can come you can come across a lot of different ways of having issues with this data, whether it is inaccurate data, duplicate data, incorrect data, and so on. And one rule that we always follow, and it's highly advisable always, is you have a priori to assume that your data will contain errors, mistakes, incorrect data, etc. And the reason behind this is the larger your data set, and the more likely to have these errors or inconsistencies. All right. So this is where big data tools comes into play. Big data refers to the large and complex sets of data that traditional data processing systems are insufficient to handle. So in the past, I will try not to go too technical, but in the past, you will use regular computers or supermassive servers in parallel to try to tackle on these issues. Now, in the digital era, there are a swarm of open source initiatives and big data tools that helps with this issue. The main feature of the big data tools is that they allow for data to be processed in an efficient way in parallel. We're talking about millions and millions of records that even regular computers are able to process them in very short periods of time. As I was mentioning, there are a lot of open source initiatives, whether it is for the analytics part, the extraction part, the storing part. You have all sorts and flavors. As you can see in this graph, there are also sorts and flavors. As you can see in this graph, you have different analytic tools, database storage tools, and so on. And this is just to name a few. If you see this image, the reference of this image is 2020. There are so many initiatives, and this will suit the needs of any technical team. So there shouldn't be excuses when it comes to use it. And the way to use them and implement it's really straightforward. Now, a part of big data, which is the part of extracting and analyzing this, is extract, transform, and load, which refers to the whole process of data integration and data analysis, right? We were discussing before the problems of incorrect, duplicate, inconsistent data. Well, during the extract, transform, and load, we can tackle on these issues. So how does this work? First, tools like Apache Spark or Apache Hadoop, they do a data extraction from different sources and in different formats. So whether it's an API endpoint, whether it is a data with a specific format, a data hosting a server, from anywhere and any source, you can do it throughout this process. Once this data is extracted and converted in a common format, right, that all of the other, that will be able to communicate with the other data sources in the same format. As you see in the image, you have the transformation engine. This is where you will execute certain rules easily with a couple of lines of codes, depending on what you want to accomplish, whether it is deduplicating data, that can happen here, whether it is correcting the data, combining the similar records into one record. Probably one record has some attributes that the other record doesn't have, right? So this engine will allow this business logic to be processed. And then you can load the unified data. You can load the unified data into your target database to be used for the purpose, for any purpose that you want to accomplish in your organization. So that's one part, right? So we can use the big data and we can extract, transform, and load huge amount of data records from different data sources, unify them, clean them up, apply a set of rules to discard or keep records, to combine records, and so on. And these tools will be really effective for that. But there will be scenarios, special patterns that won't be as easy to recognize as adding common rules in your logic. And these can be like records that follow certain patterns that at the end of the day are holding incorrect information and whatnot. When the more complicated it becomes, the more handy certain machine learning techniques comes into play. So one of the big problems in data, as we were mentioning, once you harmonize your data, once you do some basic cleanup like deduplication, etc., machine learning can help afterwards with the anomaly detection. Basically, this refers to the identification of items or patterns that are different, statistically different. These are basically outliers, different from the norm of the rest of your data. So by identifying this, you can identify records that shouldn't be there, that were misclassified, records that even records that might be duplicated, but they are not exactly the same, but they are syntactically similar. All those things can be detected through machine learning algorithm. Now, there are two types of anomaly detections, right? Basically, the rule-based anomaly detection, which can be run throughout the ETL, and the machine learning anomaly detection. The rule-based one, it's more like applying logical rules. Even you could say that an anomaly deduplication will be a rule-based anomaly detection. You could say that identifying, let's say, if this record doesn't have these attributes, then I will discard it. That could be considered a rule-based anomaly detection basic, right? So let's say if you are analyzing credit card purchases, right? An anomaly can be if it goes of certain threshold of spending, that could be considered an anomaly, and so on. However, there are especially multivariate anomalies that are very hard to detect, even for expert data scientists. And this is where machine learning techniques comes into place. Now, when we talked about these machine learning techniques for anomaly detection, you have two types: supervised and unsupervised. The supervised is really good, really powerful, and really accurate. But it consists on pre-train a model with a set of data that it will say, these ones are the incorrect ones, and sorry, the correct ones, these ones are the anomalies, right? And then you train the model, and it will be extremely good to generalize. So whenever it encounters something that seems like an anomaly, a sample never seen before, it will be really accurate, really good. So this by far could be considered the best method. However, how do we get data for millions of records to train the model, especially when you don't know the anomaly, right? So the main drawback of this approach is that it's very time consuming, and sometimes the data is not available. So it's not practical to use it. The other one, anomaly detection, the unsupervised one, you don't need a label set. It's basically based on certain machine learning principle of uncertainty, right? Some of them are clustering based, basically will associate by proximity some records from others and whatnot. And for example, in this image, by the way, shout out to AI, DALI 3, that generated this image for this presentation. Although, if you see, you have all sort of things there. You have candies, you have objects, gift, and I assume the outlier there is the human eye. If I were the AI, of course, I would have make it much simpler, just a lot of candies and then maybe one gift as an outlier, but you get the idea. So that's basically a graphical representation of a unsupervised anomaly detection. So you basically are not trained how to identify, but it's just something that using your logic will you will find out. Data scientists are really good at finding these patterns, these anomalies, if you will. But imagine a data scientist doing this with sets of hundreds of millions of records. That will be impossible, right? Unless that person lived like 100,000 years or so, maybe. So luckily we have some machine learning models. I think it's an understatement. We have a lot of machine learning models, and they keep coming. And that are from different categories based on different techniques. For example, and this is just to name a few, you have a k-means clustering, which is part of the clustering methods. Basically, if you see that image, for example, it's just associating points, right, and saying these are the minority, hence these are the outliers. So it's basically almost like a statistical method, but this in the area of machine learning. So you have one class support vector machine, SVM, which basically is it's a linear regression with an applied kernel to make it non-linear. It's really good because you have a boundary set. So it works in many different type of scenarios as well. You have isolated forests. It is a kind of decision trees as well, and you have autoencoders. We'll talk in the use case in the later about autoencoders, but basically it's a deep learning technique using neuronal networks to leverage the use for anomaly detection in machine learning. Now, just to give you an example of how easy this is to implement, and don't worry, I won't go too technical. I won't show code or explain the code in depth, but I just want to showcase these 3 lines of code are literally a production-ready one class SVN for outlier detection. So basically, the last line that says predict, and you pass the data set, that's it. And that tool, for example, is scikit-learn, and it will do the heavy lifting for you, the parallelization, the fitting, everything. So you don't even need a data scientist, an expert in big data to do this. Any developer can implement this. That's the good thing. And also, these as well are open source, fully accessible. So, and this keeps growing as well. How am I in time? Okay, good. Okay. I'll speed up. So the rule of thumb, because I show you many, we won't go into details, but the rule of thumb is always start with the simplest. As an anecdote, at Zendy, one of the first models we implemented was the language detection. And just by using one of the simplest machine learning technique called naive Bayes, we were able to implement it with a huge accuracy, which was surprising. Very few processing power. So always start with the simplest algorithm, and then if that doesn't work, try the most complicated approach. Now, I will quickly explain what we do at Zendy, how we have tackled this issue of data, what tools we have used, and as a use case of what other organizations, especially in developing regions, can do to improve their data and make it more accessible. So Zendy is an online platform created to provide individuals with access to scholarly research and literature. So in order to be able to accomplish this mission, we have to process hundreds and hundreds of millions of records. So that's quite a challenge. And luckily, as I mentioned, we have all these ecosystem of tools that can help us with this task. So there you have an image of how our process works, our data extraction process works. So basically, we have data that comes from publishers, metadata and full text data that we have made agreements with in order to accomplish this mission, plus the vast amount of open access open initiative to get these data sets that provide us huge amount of data. And they keep coming as well. I mean, OpenAlex, for example, I think it has started 2 years ago, and they are providing really good quality of data. There are a lot of these open access initiatives. Now, we unify the data from the publishers. We also unify the data from these sources, right? And they will have always, we will find records in common. So Sometimes we unify them by their unique identifier. If it is a paper, we will do it by the DOI, or we will use other methods to make sure we don't duplicate records. So we use Apache Spark for this, but there are many options out there. That's one of many. And then all these records are unified, right? And then during the unification of these records, we apply these techniques of deduplication and check for inconsistencies in the data and whatnot. And then we store all of the records. So in the whole process, we are processing hundreds and hundreds of records, but at the end, we don't have that many records because we are discarding the bad records, the outliers, and the inconsistent data. So we are getting better and better with the techniques out there, and they keep improving. Now, as you can see there, after the process unification, after we store the data in our databases, then we do an asynchronous process for anomaly detection. The reason behind this is it will be too lengthy, and this process can run in batches of data. It's more efficient to run in batches of X amount of records, let's say 1,000 of records, okay, at a time. So that's why we do it in a separate way. Now, this is very important. In our case, we cannot do the typical clustering method. We cannot do these easy methods like SVM out of the box, because we need to consider multiple variables. As most of you in this meeting know, metadata, for example, for Scholar data has a lot of attributes. These are just a few of them. And the problem with this is if you do a clustering machine learning, you won't be able to detect any pattern. So because it's the dimensionality of this is huge, so it's extremely difficult. So what we do is we use neuronal networks, deep learning, with a concept called autoencoder. So basically, long story short for this is we have a lot of dimensions that are our variables. We train a model to learn how to compress them and decompress them. So we can, this one in blue, right? It's a compressed dimensionality that is a good representation of the data. Just to make it easy to understand, think about like an architect. We see a big house, we draw it, and we are trying to do the best drawing possible of this small house. And then this small house is as very good that we could even build another equal house with just this picture. So having a small dimensionality, a very good but a smaller representation, once you have that, you can use a clustering method, an SVM method, and it will be really good. And you will be able to find a lot of patterns by doing this. So you can sort out the multivariable issue. Lastly, just to mention, at Zendy, we do more than just anomaly detection for our data. We have built an ecosystem of tools leveraging the use of machine learning. Among those are topic classification, summarization, key phrase extraction, and we are building our own assistant as well. This is for the sole purpose of not only providing the data, but helping researchers to be able to carry out and giving them the tools available and needed to accomplish this. Now, as a conclusions, big data, open source tools can be used for these three things: data harmonization and data quality. And with open source tools as well, we can build machine learning models to improve even further these data sets. the use of both can have a huge impact in developing regions. Thank you.
Thank you, Rodrigo, for this informative session. And please allow me to welcome Dr. Saeed Chaudhary. He's from Carnegie Mellon University. He will be talking about open source software and the connection between open science and sustainable development goals. Dr. Saeed is Associate Dean for Digital Infrastructure and Director of the Open Source Program Office at Carnegie Mellon Libraries in USA. He has presented at various open source events hosted by United Nations, Open Forum Europe, Open the Ireland Network, and the Linux Foundation. Please, stage is yours, Dr. Saeed.
Thank you. Thank you for the introduction, and thank you to Knowledge for organizing this conference, and to all the support team as well. My experience has been very smooth and seamless, so thank you for that. I will be talking about open source software as a key component of open science. So open source software, I simply mean software that anyone can view, use, modify, and share using a set of established licenses. I have spent much of my career thinking about open access to articles and open data as well. I am aware of many of the challenges that have been discussed over the course of 2 days, and I have very deep respect for them. And I've learned a lot more about some of the challenges that may be specific to this region and to Arabic language. So I'm not in any way minimizing those, but what I am proposing is that open source software may be a way to address some of those challenges, or at least give you an alternative pathway towards open science. One that in particular resonates with some of the themes of this conference around democratization, around community building, and around sustainable development goals. And the OSPO in the title is Open Source Programs Office. This is a new movement within US universities, which I think can help us better manage open source software to help accomplish some of those goals. So I'm going to begin with this description of open source software and the sustainable development goals. So it's already a part of the sustainable development goals to something known as the digital public goods. So these are open source tools that are developed by definition. They are open source in order to be digital public goods. And of course, open source software is a key part of the university research system as well. The open source programs offices that I had mentioned are a new construct that's happening in universities, and I'll talk a little bit more about them later on. And I recognize that I'm giving you a US perspective, but I'm hoping that there are some points of connection, particularly through this concept of the OSPO. So I'm beginning by talking about the state of open science and policy in the United States. This is a screenshot from a memorandum that was produced by the White House Office of Science and Technology Policy in 2012. What it basically stated was that any outputs from federally funded research, particularly articles, must be made available publicly, and that any federal agency that provides more than $100 million of research and development funding has to come up with a plan in order to make that happen. So more recently, last year, that memo was in essence updated with a new memo that also came out of the Office of Science and Technology Policy, and it did a few important things. It removed the embargo on those articles, basically saying that they have to be available immediately, they cannot be embargoed, and mentioned data specifically in addition to articles, and then also removed the $100 million threshold. So any federal agency in the United States providing research and development funding is now beholden to come up with policies around this. And even more recently, the Biden administration in the United States has issued a statement from several federal agencies, starting with NASA, the National Aeronautics and Space Agency, around 2023 being the year of open science. I did speak to a program officer recently and said, well, it's October. Does that mean the year will end and that'll be the end of it? And of course, he said, no, this is the beginning of a longer term effort. So it's not only the year of open science, it's basically the launch of a much larger movement. This is the definition of open science from that fact sheet, as it's called, and you can just read it for yourself. I know that UNESCO has an entire toolkit around open source and has its own definition as well, which I think is more expansive in some ways, but it has a lot of the same kinds of themes and common elements, including, collaboration, reproducibility, And it's worth noting that both statements also talk about disciplines beyond the sciences, like social sciences and humanities. So this is a diagram that I've used a fair amount to talk about the US landscape around open science and the associated policy. Moving from left to right in this diagram, you see papers or articles, data, and then software, and the lines that show the connections between them. So papers and data tend to have this sort of linear mechanical citation type link, whereas the connection between data and software tends to be much richer, much more complex, much more multidimensional. And I'll get into this a little bit later when I talk about the OSPOs, but the lines to the right that come out are basically what we hope OSPOs do, which is make the software better managed and better curated and better supported so that it can have impact beyond the walls of the university itself. Now, while those policies I've described in some sense have gone left to right, they've started off with articles and now starting to think about data, did not mention software specifically, but I spoke with one of the authors of the most recent OSTP memo, and he said the reason for that was the US wasn't aware if universities were ready to deal with some sort of policies around software. So these OSPOs that have been created in some sense is a response to that. But what I'd like you to think about in some sense, and maybe this is very fitting for a conference here, is what if you moved right to left in this diagram? So researchers don't typically start off thinking, here's the paper that I'm going to publish, or here are the papers that I know I'm going to write. They tend to think about what are the data and the software that they're going to work with, process that over time, come up with insights, and then produce the papers. So from left to right is very much sort of a curation perspective, but right to left is much more about the researcher's actual way of working. It's much more about the workflows and how they arrive at their conclusions. A couple of case studies that demonstrate this theme of moving right to left. So prior to being at Carnegie Mellon, I used to be at Johns Hopkins, and I was involved in a project called the Sloan Digital Sky Survey. And of course, we heard that this region has a very strong history with astronomy, so maybe this is especially fitting. So at the top left of that diagram, you see the actual telescope that is used for this project in a state called New Mexico in the United States. And astronomers describe that as level 0 data. And then as you move further down and to the right, the data get processed from level 0 to 1 to 2 to 3. Now, I was told by the astronomers that there are about 12 people in the world who can interpret the level 0 data that comes right off the telescope. And I used to say to them, would you make sure they're never in the same room or on the same plane? I mean, it seems like a fairly important group of people you have. So what happens over the course of the processing is the data become much more accessible. And so by the time it reaches level 2 in this diagram, most astronomers, professional astronomers, could start to interpret the data. But what the astronomy community decided was, why stop there? Let's keep processing these data to level 3 and then make them available to the public. So there's this entire resource of data available through something called Sky Server. It's hundreds of terabytes of data that you can analyze. A lot of the big data tools that you just heard about, some of them were developed in this project. And you have this tremendous democratization now. There are about 10,000 professional astronomers in the world. There are 1 million people with an account on Sky Server. Now, not all of them are active, I understand, but if 50% of them are active or 25% of them are active, that's quite something. And there is a school teacher in the Netherlands who discovered a new astronomical object using the Sky Server and using something called Galaxy Zoo. And when the astronomers discovered this, they turned the telescope to that portion of the sky to study it further. So you have someone with no professional training in astronomy actually influencing the experimentation in their field. Now, astronomy has one benefit that you heard about earlier from Rick Anderson. The data don't have any constraints. There's no privacy issue, there's no commercialization, there's no legal constraints, there's no clinical data, there's no privacy, so on. So they had the great advantage of the data being open. And that is particular to astronomy, but it's the combination of the data and the software that have allowed this kind of processing to happen and for this kind of democratization to happen. Now, as you start to think about disciplines that don't have that kind of openness of data, including a project that's going on at Carnegie Mellon called the Cloud Lab, which I'll just describe in a second. When I was at Hopkins, I was a member of the team that supported the COVID-19 Global Dashboard. And I learned more about virology and other types of things than I ever want to know. There was a lot of work at Hopkins that influenced at least, sort of the COVID response and the vaccinations. And the interesting thing is that the physicians and the researchers I spoke to told me preprints were great. We had access to articles. We still couldn't share the data. They were still clinical data. They were still held by laws and privacy issues that did not allow us to share the data openly, but we could share our code. So we shared our software with each other and learned about the data that were being processed and what was being done from an analysis perspective. There's a community trying to develop a data standard for electron microscopy, and apparently they've tried this 50 times. There are over 50 data standards for sharing electron microscopy data. They have shifted their approach to common open source base. And they're basically saying, hey, if we all use the same software, we have to agree, right, on how the data are going to be shared. So let's not think about this in the abstract, but let's get down to the code level and start doing this. So Cloud Lab is something that was developed in the state of California by a CMU graduate in a group called Emerald Cloud Lab. And it was designed initially for private startup companies in California. It's basically a remote controlled laboratory, a very large, sophisticated, diverse set of experiments that you can do using software, protocols, physical machines, hardware, robotics, and actual people in the lab moving things around as well. Carnegie Mellon is building the first one in a university setting. So there's actually a workshop going on right now at Carnegie Mellon to talk about launching this for not only Carnegie Mellon, but perhaps on a national network within the United States. And I've been in discussions with this group. Now, remember, it started off as a closed system. Private companies in California don't want to share data with each other. So it started off very closed, and we're slowly opening it up. And one of the ways we've argued about that is if you want to support open science, right, you have to start somewhere, and software is a good place to do that. Even if the data can't be shared, even if the protocols may have commercial value or so on, the code should be openly available, right? Why not have that be open source? So I'm glad to say the company has open sourced their programming language, and they're encouraging this community development around this and building an ecosystem. And I think that will give you a pathway into the workflows in a very significant way that would be really hard to do otherwise. So this is a report that came out of the U.S. National Academies for Science, Engineering, and Medicine, looking at these automated workflows and the impact of machine learning and AI. And this is a quote from that report that you can read on the screen. But the main point being, there is growing evidence and belief that machine learning will, of course, help us explore lots of different results and think about how we might explore all those spaces in a way people simply cannot. We just don't have the processing power to do so. But AI might actually take the next step and help people design experiments, help the researchers think about the next set of experiments. So while a school teacher helped the astronomers, we're now talking about AI helping researchers think about these types of things. With machine learning and AI, that boundary between articles, data, and software will blur. They will all start to come together into these large language models along with algorithms and weights and so on. And it will be really hard to say this whole thing has to be open. I'm not saying it's impossible, but it will be a real challenge to have completely open large language models and AI systems and tools. Again, the software will be a pathway. If the software at least is open source, then I think we have a pathway to understand earlier stages of the research cycle and how those stages progress to ultimately having impact beyond the core research team. So I hope I've given you something to think about in terms of open source software and its potential in this regard. I say it's the best pathway to think about the entire research workflow. I get a lot of pushback about this, so I'd be happy to hear your opinions about this. But I do believe that. I think if you actually want to understand what's happening earlier in the research process and what the workflows are, open source software is the way to do that. It's also incredibly important for reproducibility. There are many funders and program officers in the US who say, we of course believe in open data. We want to support that, but we recognize that open data might mean I send you a spreadsheet and the column headers say something like SP12. Okay, so you may have no idea what that is. I may never tell you. I may not remember. It may have been my graduate student. So if you don't have the software along with the data, it's hard to think about the reproducibility in a full way. The FAIR principles you may know of, findable, accessible, interoperable, and reproducible, I think are critical to have software, open source software for that. And the CARE principles, which maybe you're not as familiar with, collective benefit, authority to control, responsibility, and ethics, is a way to engage a lot of local communities in a way that gives them a sense of control and agency around how their data are used. And this will be really important as we start to think about things like, sustainable development goals. And then finally, open source software by definition is transparent, and it fosters a sense of trust because of the transparency. Even if I can't understand your code, the fact that you're saying, here you go, you can take a look at what I'm doing, is a very strong statement. It mentioned these open source programs, offices, or OSPOs. This is something that has existed in the private sector in companies within the US for over a decade now. It has grown in the private sector, so it isn't just Microsoft, Google, and Amazon that you might think of, but American Airlines, Walmart, other companies that are not tech companies or software companies use a lot of open source, so have these offices to manage that. In the private sector setting, it is much more about legal issues and compliance issues and development practices and financial concerns and so on. All of those are important. But in the university context, we have an opportunity to think about all these kinds of issues that I've just been talking about above and beyond that. So there are a few universities in the US that have now formed these so-called OSPOs. I started the first one when I was at Hopkins. Now I'm at Carnegie Mellon, so I guess I'm running the second one. And at Carnegie Mellon, it has this role of being a community convener, a center of competency, and so-called organizational API. And what do I mean by that organizational API? So when I first arrived at Carnegie Mellon, I thought it would take me months to convince people that this was a useful thing to do. So literally about 3 weeks into my job, I'm talking to a faculty member and doing this pitch, if you will, and he stopped me and he said, stop. There's open source software everywhere at this institution. Everybody understands its value, and we need this. So just move right to what your OSPO can do for us. So imagine if you wanted to find out about open source software at Carnegie Mellon. Who would you ask? How many people would you have to speak to? How many different answers might you get? So the OSPO is that API in the sense that you come to the OSPO and we can basically say, yes, we think this is open source software is being developed, or we know this researcher has that kind of interest. And you don't have to understand all the complexities of a university like Carnegie Mellon, or any university for that matter. And then internally, when students or faculty members are curious about what's happening, they can come to the OSPO and we can be that hub or clearinghouse for that kind of information. So it's starting to become that place, that one place you can go to learn about the state of open source within a university. Now, recently, the Sloan Foundation, the Alfred P. Sloan Foundation, is the one that has funded 12 universities to create these OSPOs, but also gave an additional grant to Carnegie Mellon to do coordination work around those 12 OSPOs. So I'm the project director for that particular effort as well. And in essence, we're now trying to think, can we think of these 12 OSPOs as a network coming together to provide that kind of organizational API for all 12 universities? Are there common practices? Are there common licenses? Are there common research workflows that we start to develop so that it makes it easier for those institutions to work together? I'd like to believe that this can be a model for other universities in the US or beyond the US. One of the wonderful things about open source, it doesn't have those boundaries. It doesn't have those sort of constraints. When you typically work across universities, it's through grants or data use agreements or business associate agreements and all sorts of other legal agreements. While open source software does have legal conditions through the licenses, it's a much more seamless way for people to work together. And it's a seamless way for anyone, even if you're not affiliated with the university, to work together. There are individuals that can make contributions to this, whether they have a university affiliation or not. So there's this network of OSPOs, a way in which we can start to work across different regions. Now, again, I recognize that at some fundamental level, working in software flattens a lot of the expressiveness and the issues around language, for example. But if you're willing to agree to that, I mean, I don't write code in natural language, right? I have a particular syntax and a particular set of logic that I have to conform to. Then I think there are real opportunities to work together. So let me turn to the Sustainable Development Goals. You may be familiar with these. They did come out of the United Nations, but Carnegie Mellon has really embraced these goals, both internally and as a driver for our research and education. And I'm told by some experts that they really aren't UN goals per se anymore. These are supposed to be sustainable development goals for people all across the globe, even if you're not affiliated with the UN. There are 17 of them. They were started in 2015. The goal was to reach significant progress on these by 2030. There was a recent summit in New York to look at the state of where the SDGs are, and it was fairly bleak. There was recognition that about halfway through, we are not halfway through the goals of actually advancing the SDGs. So what can we do to accelerate or change the dynamics? And I happen to believe open science is a really important driver in that regard. So you may not be familiar with something called donut economics. If you Google that, you should be able to see a group that's forming this, and it's led by someone, or started by someone named Kate Raworth, who's a classically trained economist, but has come up with this alternative idea of sustainable growth. So not infinite growth, continuous, ongoing types of growth, but sustainable growth that recognizes two things: that there is a minimum level of capacity and life that people need. That's that inner circle. So you want to be beyond that inner circle for things like your health, for your water, for education, and so on, things that sound like sustainable development goals. It is inspired by the SDGs, but that outer ring is a limit in terms of what the earth and maybe what our societies can actually carry without it becoming destructive. So how do you balance that, and how do you regenerate that? Regenerative farming, solar, renewable energy, and so on. So trying to stay within that ring, or the donut may not have been the best metaphor to use, but nonetheless, trying to stay within that ring or that donut is really the goal of the donut economics model. And it is inspired by the Sustainable Development Goals. And there are actually people who have mapped the sustainable goals to this donut economics model. And there are many of them. I'm just showing you one. And one thing I'll point out is a key part of measuring the progress around these SDGs is these voluntary reviews, which started at a national level. Like, what is the state of these 17 SDGs within your country? And what is the movement over time based on those reviews? Those reviews are now being done on a city level. And I'm very proud to say that Carnegie Mellon is the first US university to do that at the university level. So they can be applied in different levels of context, be it national, city, institution, take your pick. Even small communities are starting to do this at the neighborhood level, doing these sort of voluntary reviews. And what those reviews do is basically give you a sense of what progress or not that you're making in terms of these goals. So in essence, it would be somewhat like, do you move within that donut? Are you below that? Are you above the outer ring? And are you making movement? The voluntary reviews can help us think about that. So I will give a very specific case of why I think this is an interesting framework. There is work at Carnegie Mellon to create these environmental sensors using open source software that are used to measure air pollution. So they were used within the city of Pittsburgh. There was a community that basically said, our air quality is terrible. We can tell simply by our health effects. And the city of Pittsburgh, I'm not saying there was anything malicious or anything sinister here, simply didn't know if that was the case, and basically said, how do you know that? Well, what basis do we have? These sensors were given to the community. Some of them can actually be run off your phone, for example, at this point. And they measured the levels of air pollution and showed the city that, in fact, this was the case. And because they're open source, they're now being used by CMU researchers at our Africa campus in Rwanda. And they can be used by anyone at any level to do this kind of work. So SDG goal 3.9.1 is about reducing deaths and illnesses from air pollution. If the city of Pittsburgh can now see progress in terms of reviews and see the lines come between those into that donut because of the work that CMU helped, that to me is the way we can tangibly connect open science to the Sustainable Development Goals. So at yesterday's keynote, Dr. Salvatore Arrico mentioned that many researchers claim what they're doing is helping the SDGs. And upon further examination, that may not be true. But if we can connect it to this very tangible set of measures and the reviews, then we can, in fact, argue that some of these things are having impact. And I think that's where open source software has a lot of potential. So I will end and just note the Creative Commons statement. So there's a plug for that. And they'd be happy to take questions or be part of a discussion. Thank you.
Thank you so much, Dr. Saeed, for this insightful presentation about the open source software, and which highlighted also the open source program office. We start with the questions, if there is any in the room or online. Well, maybe I have a question to Rodrigo right now about your the initiatives. You have a concern about data quality. Are you applying kind of standards like I know ISOs have part of their standards for data quality, maybe ISO 8000, or maybe you are applying other or following other standards?
That's a good question. At the moment, no, because the problem we tackled first is like the initial problems with the data, right? An ISO standard, usually it goes beyond that. But when we are talking about inconsistencies, for example, we have found several patterns of inconsistent data. For example, by using this anomaly detection, we have detected certain records that had an incorrect publisher and that were leading to a incorrect link, discovered just by machine learning somehow determining that this record existed. Imagine going through hundreds of millions of records. So yeah, no, we are not using ISO, but because the initial problems we are trying to tackle are like, I don't know, let's call it more basic problems that are like more crucial in order to be able to provide accurate information.
Thank you. Said, I have a question for you. I would really like to pull out the final comments that you made with regards to measuring impact and the role open science may have around that, because now we see the correlation between the research that is published and it's linking it to the SDGs, which I'm not feeling that it's 100% accurate. And we see the rise of, for example, impact rankings worldwide, where actually universities are measured based on their contributions towards the SDGs again. And again, it's paper-based and article-based related to the metrics, finding the correlations between, it could be just a mention of the SDG, not necessarily impact. Could you elaborate a bit more on that? Because I find it very interesting, the use of open science software to actually find real implications. It would be great to hear more thoughts around that. Thank you.
Yeah, I'd be happy to elaborate. So one thing it's important to make clear for anyone working in university, I am not here to tell any faculty member what type of research they should be doing or how they should be doing the research. And there's a lot of research that's very basic and somewhat theoretical, abstract, so on. So this is not a one size fits all approach. But in the cases where we have researchers saying, I want to make an impact, and I want to be able to say we're supporting the Sustainable Development Goals, then I think we need additional, arguably better ways of measuring that beyond the article. And I think that in some ways, some of this will be very difficult to do. So I mentioned Cloud Lab, for example. There will be a lot of material scientists using that facility who may help develop better batteries. And that's a long-term kind of impact for clean energy and so on. So it's not going to be this clear point-to-point connection in every case. But if we can identify cases where it's quite clear that the use of research that's coming out of universities helping address those goals, we should be very clear and celebrate those. And it doesn't have to be around open source software, but I think open source software lends itself, naturally to having that kind of community engagement or awareness building or clear, tangible kind of impact. And I think there are many researchers who appreciate that, who would actually be willing to say, yes, thank you. You've given me, evidence to show that I am making an impact.
Good afternoon, and thanks for the presentation. This is the question for Rodrigo. With regards to the data, when you filter it, you say that there are some useful data and there are some non-useful data. And how you difference that, as well as if there is, the data should be right or wrong, but what is the meaning of useful data and non-useful data? Are the researcher going to use that data or not in the future? If not using, are you keeping those data or not, or deleting it? What would be the answer? Yeah, thank you.
Good question. And I think there are more than one question. So I'll try to answer all of them. The first one, you said something like what will be the criteria, right, to keep or discard a record? What marks that if a record is good or no, right? By doing anomaly detection, for example, it detected outliers, and when we were seeing, for example, just to give you an example, the publisher name was something unreadable with strange characters. So obviously that was something to be discarded. It's not like we leverage the use of big data and machine learning to detect these anomalies, but the action we take once these anomalies are detected are determined by our data scientist, not by the machine learning models itself, right? That's why I also emphasize the use of multivariables, and because they are not easy to find, that's why we compress them using machine learning, and then it's easy to spot anomalies. And it's interesting that we are able to see things that a human would not be able to. That was the first one. And the other question was about, you can remind me?
Whether we can keep those data if there is no useful data. Oh,
Correct.
yeah.
Usually, even if the record is inaccurate, right? Not duplicate. If it is duplicate, it's a different story. But if the record is inaccurate and we don't have a counterpart, we keep it for future reference. So we have something to compare with in the future. Now, if it is a duplicate, we merge. Let's say you have with the same identifier, for example, the DOI. Two records come from two different data sources with the same DOI. Then we combine them. We execute a set of rules and to see which attributes from each record we should keep and which not.
Dr. Rabab have a question, please. There, Mike.
Very small question to Rodrigo. Thank you both of you for the insightful presentation. For these Zendy, well, have you come across like Arabic language research, like to be published through the Zendy? And I mean, like, does it accept, like as a platform, does it accept any Arabic language papers or research? Any challenges, for example, you face when you receive or come across such papers? And any future, for example, like projects to try, like, for example, to solve these like challenges, for example, or to add Arabic language?
Good question. And this goes beyond the techniques we use in big data and machine learning. I will say we have material, by the way, in Zendy. I hope you can subscribe afterwards and check it up. And we don't have enough yet. I mean, we consider we could have more and more. I will say in terms of the quality of data, I mean, anomaly detection, harmonizing the data, it's the exact same process, whether the language. Now, what we have are problems beyond that, cosmetic, I will call it, problems, like how to display it, make sure like how we display the papers are right to left instead of left to right, right? That is readable for Arabic readers. But other than that, the rules and detections are the same. When it comes to anomaly detection, the machine learning models are agnostic of the language. It will process and detect anomalies in the same way.
Thank you so much. Thank you for
We have an online
another
question here.
question. Oh, please.
Oh, yeah. Open science initiatives are leaning into open source now, but the publishing system refuses to lean into open source and continues to rely heavily on the commercial publisher, with significant consequences for data liking, author rights, and limitations on access globally. Why do you think this is so? When we talk about open source solutions, why does this not reach the publishing system? This question is for Said.
I was worried it was for me. It's a good question. It's a difficult question to answer, succinctly, I suppose. So one thing I would say is, I talked about the advantages of open source in terms of sort of inherent attributes. There is a very well-established ecosystem, if you will, around publications, and there are very clear stakeholders and entities that have developed that ecosystem. And there are financial reasons why some do not wish to see that change in a fundamental way. That's simply, now, open source software is supported by some of the largest companies in the world right now, but they have not gone so far as to say, we're going to take over the open source software and we're going to run it on our own, because then it doesn't tend to be open source. So if we could go back in time and reboot the sort of initial conditions about how publishing is done, then we may have a very different set of circumstances today. But the publishing ecosystem is one that potentially needs to be re-engineered, whereas the open source software one is that we're sort of naturally building on the early initial conditions that made it more conducive to that type of work. But I will also say that large publishers use a lot of open source. And in some cases, they're actually producing some open source, and certainly a lot of the AI tools that they're using to do some of their new tools and so on, many of those rest on open source as well.
I just wanted to add as an example to the question. So we have, when it comes to the world of publishing, we have the PKP having the OJS open source software that is used by, I think, latest number I heard was over 4,000 journals are using the OJS, including we are using it for Caney publishing platform. But when it comes to open source, there's a start point and there's an evolution of the software that is available. So let's take learning management solutions. You all heard of Moodle. There's only a certain limit where the open software has developed. And basically the business models come on top of that in terms of further customization, changes, redesigning, so on and so forth. There are commercial companies that start from on the basis of open source software. But again, I think it goes back to the discussion that Rick was mentioning about the economics behind various solutions. Somewhere, someone has to pay the bill. And for example, when it comes to open source software, if there's not a sustainable model to fund it to continue, then of course it has limitations. For example, there was a time where Google Scholar had only a few individuals supporting it, yet it was used by many millions of individuals around the world, but it did have limitations, and those limitations, some of them are still there. So it's the start of many ideas can be in open source, and it can be a major contributor to further developments and further use of it. But in the world of publishing, some publishers maybe started, but then they've gone to hosted solutions, because again, when it comes to features and functionalities, there's so much work and investment that needs to go into it, where an open source will not be able to support it. And if there's further investment, there then needs to be a commercial return to cover the costs, or there's sometimes something extra as well for the entity to move forward. So it's to understand that open does not mean free It means, again, I started the conference by talking, open to me means reducing the barriers and making it more accessible. And sometimes we need to be creative in the way that we do it, but definitely customization, further enhancing, fine tuning. So in these government projects that you mentioned, there's funding behind it.
Mhm.
So the more funding that we can do for the good of humanity and people using it, then the better. Then it would reduce the dependency on sometimes some commercial solutions.
Yeah, I'll use an open source cultural norm and plus one that everything you said, and I'll add that I think one of the roles of these open source programs office is to help researchers think about the community building effort earlier. So I think the most successful open source projects have community building infused from early stages throughout. And in the case of something like a Moodle or many other types of things, it may be that there wasn't that roadmap attached on how do we continue to build a community of contributors and users, which one might argue the private sector is better at doing in some sense, sort of the market analysis and so on. So I think that that's a really important point to add to your very insightful comments.